Okay, into section 2.3, pretty much continuing our discussion of lines in this case. Okay, so 2.3, we've already defined a linear equation, we've solved linear equations, we've graphed linear equations. So now we want to, which we just mentioned slope in the last section, so we're going to discuss slope and equations of lines in this section. Shut off this one. All right, so these are the different equations of lines that we want to discuss in this section. We want to be able to, given some information about a line, we want to be able to come up with the equation of that line in all three of these forms. These two are going to be more common than this one, but you'll see this one also. So we want to be able to come up with the equation of the line in all three forms. And again, the things we're still interested in, just like we were before, what is the domain of the function, the range, where lines are either going to be increasing along the entire domain or decreasing, right, because they're lines. So the increasing, decreasing part really doesn't affect us. If it's a line that goes off in each direction, and again, it's a polynomial, so it's going to have a domain of all real numbers and a range of all real numbers, unless it's horizontal or vertical. We'll get to those cases in a minute or two in this section also. Okay, so what we want to do is, first of all, let's define slope. Slope is, we're going to call this lowercase m for slope, and the slope is going to be given 2 points on a line. And so given 2 points, x1, y1, comma, and x2, y2. So any 2 points, right? 1 point, 2 points. Take the difference in the y's over the difference in the x's. Notice this is how we did the difference quotient, right? We took the 2 points on the curve, drew a straight line between them, and we found the slope. That's really what the difference quotient was. So in this case, let's say, given these 2 points, 2, 3, and 0, -7. And we're asked to find the slope. It doesn't matter. It doesn't matter which point you call point 1 and point 2. Either way, you're going to get the same slope. So just label them as the first and second point, just so you keep the order straight of what you're subtracting. But if you name this one x1, y1, and this one x2, y2, you'll still get the same answer. So here we'll just use it like this, and we'll say difference in the y's over difference in the x's. -7 minus 3 is -10, and 0 minus 2 is -2, so we end up with a slope of 5. Excuse me. So that's how you find the slope. So you need the slope because you're going to put that into this equation, you're going to put it into this equation. It doesn't show up in this equation, but slope is a rate of change. It tells you what a function is doing, how it's increasing or decreasing. If the slope is positive, if we have a line that's increasing from left to right, then the slope is going to be positive. If the line is decreasing from left to right, then the slope is negative. Okay. We'll deal with horizontal and vertical lines in a couple minutes. If the line is horizontal, then the slope is 0. And if the line is vertical, it has no slope. Slope is undefined. Since I have these vertical and horizontal lines up here, I might as well discuss them while we're here. So a horizontal line Now these are horizontal and vertical lines are special cases to these equations. They don't follow these particular forms, so these are special cases. Horizontal line, the equation is always just going to be y equals whatever number that line is going through. Right? So in this case, the equation of this horizontal line is just y equals 3. Whatever the b value is, whatever y value that horizontal line is going through, notice every single point on this horizontal line has a value of 3, whatever that value is. So I'll just use a b for any value along the y-axis, and that's the equation of a horizontal line. So it doesn't follow those other equations. It's a special case. And similarly, for a vertical line, the equation is just whatever that x value is that it's going through. Right? We'll call this b. So we can match it to this, and we'll call this a, so we can match it to this. So these are special cases. Vertical line, horizontal. See anything else I got to mention there? So the slope is 0, slope is undefined. The range of this is just that number b. The domain of this is just the number a. The domain of this is all real numbers. The range of this is all real numbers. All right, so that's how we find a slope. And we've taken care of the horizontal and vertical lines. So let's look at our equations over there and see what we're being asked to do. All right, so let's look at I'm just going to make up numbers here. Let's say we're given 2 points on a line. Say 3, -2, and 1, 5. And we're asked to come up with the equation of that line in all 3 forms. That's really what we're trying to do. All right, so first we need to find the slope of the line. And we're given 2 points, so that's pretty easy, right? So again, it doesn't matter which point you call x1, y1, which point you call x2, y2. Just be consistent once you make that choice. And here we can say the slope again is the difference in the y values over the difference in the x values. So 5 minus a -2, just be careful with the double negatives, and 1 minus 3. So we end up with 7 over -2. We generally like to put the negative in the numerator like that. Okay, so that's our slope, -7 over 2. So if I want to come up with and so what we're talking about here, the x1, y1 here is either one of these points, right? Because we could have chose either one to be x1, y1. So that's what you're putting in here or here. So for point slope form, depending on if you're given 2 points like this, depending on which point you use, you're going to get a different form of the point slope. So here, point slope form, if we use the point 3, -2, and the x and y we leave as variables, right? This x and this y are it's an equation in x and y, right? So we're not plugging anything in for this x or this y, we're plugging in this x1 and y1 and the slope that we just found. So here we're going to get y minus a -2 equals the slope that we just found times x minus 3. Now if you just ask for an equation of this line, that's good. If we go over here and use the other point, 1, 5, then this is going to be your x1 and that's going to be your y1. So now we get y minus y1, the slope is the same, and then x minus 1. So either one of these is good for point slope form. Now what you're going to notice, to get from point slope form to slope intercept form, all we do is solve for the y. So we take either one of these and solve for y. What you're going to notice is we're going to get the same thing if we did this step right, even though these two look different because we use different points. If I solve each one of those, if I did it right, I'm going to get the same thing. So let's try that. So to get slope-intercept form, slope-intercept form, just solve for y. Okay, so let's distribute the -7/2 first. So we'll get y plus 2, -7/2 times x. And negative times a negative gives us positive 21 over 2. I just made these numbers up so we're getting fractions, but that shouldn't worry us. And then we're going to subtract 2 from both sides. So we get -7/2 x plus 21 over 2 minus 2. So let's put it over 2 so that we can combine these, right? -2 is -4 over 2. So we end up with -7/2 x plus 21 minus 4, so plus 17 over 2. And that's slope-intercept form. Now notice if we use this one, we should get the same thing if I did everything right. So once again, we'll distribute that -7/2. And negative times a negative gives us a positive. And then we're going to add 5 to both sides. So we get -7/2 x plus 7/2 plus 10/2, which we're going to see is going to add up to the same thing. So that means we did it right. All right, so that is slope-intercept form. So notice you're going to get two different equations depending on which point you use for the point-slope form, but if you did it right, both of them will reduce down to the same slope-intercept. And then general form is just putting everything on one side and setting it equal to 0. So that's really the easiest one. Once you get these, for this one, just bring everything over to one side and set it equal to 0. So general form we'll say y, we'll bring everything over to the left-hand side, so this negative becomes a positive, plus 7/2 x, and the positive 17 over 2 becomes negative 17 over 2 equals 0. All right, so we want to be able to come up with all three forms. And the given information will sometimes you'll be given a point and the slope, and you won't have to go through this step. If you're not given the slope, then you need to use the two given points to find the slope first before you move on. And this is the order I use. Some people do it in a different order. I find that this is the best method no matter which form you're asked for. I think finding point-slope form first is always the easiest. As long as you show work, you can try this if you know, but a lot of times you're not going to know what this b value is either. Because it's the y-coordinate of the y-intercept and you're not always given that information. But you can start wherever you'd like. I find this is the best method. Start with point-slope form, because then it's easy to get slope-intercept form from that, right? We just solve the point-slope form for y to get the slope-intercept form. And once you have the slope-intercept form, it's really just trivial to put it into the general form. So we want to be able to do that, given some information about a line, be able to come up with the slope if you have to, come up with all three forms of any equation. All right, I think that's good for 2.